Okay, this week we will talk about linear programming. Linear programming is a very useful technique, especially for the planning um, and the limited resources. Right? Assume that you are a manager in a company. You have a limited resource such as material, labor, and money. Right? You have different products. You need to make decision to maximize or minimum maximize the profit or minimum the cost by using the um, limited resource. And sometimes it's not only resource but other outside constraint like existing orders, right? And the linear programming will help us to do those kind of work very easily with the help of Excel. And during this week, we won't have a data file um, to access on. We will create our own Excel file. And so every information is in this question, right? And for linear programming questions, they are almost same, right? They have a constraint, they have variables, they have um, ob- they have object functions, right? So the thing is you need to figure out how well what are those? What are those important information? So let's come to the first question here, make an example here. So first thing is you need to figure out what are the variables, right? Normally the variable will be products or options you have. And for here, this company manufactures two products. It tells you there are two products. One is called air conditioner, and another one is called fans, right? So those two are important information here. And another thing is what is the cost or what is the profit, right? There are two processes. Assembly process, right, um, require two. One is wiring, another one is steering. So each air conditioner takes 3 hours wiring and 2 hours steering. That's the cost, right? Cost for air conditioner in each process. And the fan costs 2 hours and 1 hour for wiring and drilling, respectively. And we only have 240 hours of wiring. That's the constraint, right? 140 is not a constraint. And each air conditioner sold as 25. That's the profit per unit. Each fan is 15 per profit per unit, right? So we want to make sure um, this one's production situation to fit the best combination of air conditioner to yield the highest profit. That's our object. Object. Okay. So the first thing is different from other question. Um, for this type of question, you need to write out um, the linear programming model. You need to write it out instead of go directly for the Excel. You have to be able to write them out. And the standard format is at your lecture material. Right? This is the standard output. Standard output in page 37 in your lecture handout. Is taught by Professor Mangesha. Yeah. So what we need to do is we write out the list first. Then we do the Excel solver. Okay, first thing is you need the first step is step one, right? Step one. Step one would be let. Right? We have two products like X and Y. Right? So right, X and Y be the number of units per to produce for AC and fan. Right. So this is your first step. You need to define the variables x and y. And the second step, step 2, is the constraints. So first constraint is varying, right? So the varying constraint is 2 multiplied by x, right? It's here. 3 hours of varying. 3 times x. 3 times x plus 2 times y should be less or equal than 140. 240, sorry. 240. And the drilling will be 2 times x plus y, right? 1 times y. 1 times y should be less or equal than 140. Right, so those are your constraints. Don't forget we have a non-negative constraint, which is x, and y greater or equal than 0. Right? And the step 3 is the objective function. Function. So we want to max our total profit equal to here 25 and 15, right? So equal to 25 times x plus 15 times y. Okay, so here is the 3 steps to define the linear programming model. Okay, so in the test, you have to write this out first. I don't care whether you write in the Excel or in the Word or in the Sakai comments. Right, just write it down. This is first half. Right, until here you almost have finished half the exercise. And after that, we need to create an Excel functions to solve this problem, right? So, and when we do that, we is same as the step. Like let's say first is units for this is AC, or you can say X, right? So these two are the decision variable. We want to make sure we want to make the decision on those. So before we get the value, we don't know that. So those are decision variables, right? And we have varying, and sharing. Right? So the varying is 3, 2, and 2, 1. Okay, so those are the costs. And we have total here. We don't add different units together, but we can do here, which is equal to number of units times is varying, and plus number of unit of fans times the cost of fans for varying, right? So this is the total cost for varying, and we have if we drag to right, this is total cost for drilling. Okay, and we also have the profit, which is 25 and 15. Right? So the total profit is the same formula here. Let's see from here, right? This one times this one, this one times this one. Okay, so in Excel server, we by default the non-negative is applied. I will show you shortly here. Let's make it bigger. Yeah. So you can write that out, but or you can ignore that if it's owning the thing here, right? But it's better to add it out if you want to do it um, in a more serious way, right? So first we write out the constraints, and the total variance should be less or equal than 240, 240, and the drilling should be less or equal than 140, right? And we have non-negative constraints, so this one should be greater or equal than 0. This one should be greater or equal than 0. Okay, so this is those are constraints. Let's make it different color here. Those are constraints, and finally, this one is the objective function we want to do, right? We want to do. So by changing these two cells, we want to get this one, the max. So how to do that? In Excel, we have data and a solver. If you don't have this, go back to the regression session. There's Excel add-on, right? From there, you can add the solver to Excel. So use the solver, and the objective would be here, right? We want to max, right? This is important. If it's max, question ask max, you do max. Question min, you do min. Question exactly of do that. By changing the cells, is our decision variables, these two, right? And we with the constraints at, so we can choose these two cells. These two cells should be less or equal than these two cells. The cells F13 and G13, right? F13, G13 should be less or equal than F15 and G15, right? So this first constraint. And the second constraint is the units should be greater or equal than, you can type 0 or you can choose these two. Right? If you use 0 is the same, you can say 0, right? Okay. So by default, you can see here, make the unconstrained variable non-negative. So if you don't have this one, you still get a correct answer, right? The last step is very easy to be ignored here. Change this one to linear, simple LP. Okay, if you don't do that, sometimes it's a different answer. Okay, sometimes right, sometimes wrong. I don't know that if you do the lab test because I cannot see this page. I only see the result. But if the result is wrong, I won't be able to tell how you made it wrong, right? I will say it's wrong. Okay, just make sure always choose simple LP for this class. Okay, then solve it. Okay, now you can see the Excel automatically fill the numbers 40 and 60. With the maximum profit 1,900. Okay, so then the problem is done. Okay, you should produce 40 air conditioner and 60 fans to get maximum profit 1,900.